guys, it's Miss Marshall. This week we are going to do a science experiment. So instead of me doing an activity, a little extra something that I normally do every week, I'm just going to do the science video activity. This goes with the worksheet that is in your packet. I wanted everybody to just see one video instead of two. I didn't want to confuse anybody. This video that I'm doing right now is to help you answer the questions on that science page that is for a grade, okay? Is the science page that I'm referring to. This week we are going to create a sun tracker using a piece of paper that I had with my materials from our science kit. It's the sun tracker. I had to print it out on my printer at home. A piece of cardboard, some clay, a straw, and glue. Instead of using clay, I'm actually going to use Play-Doh because I don't have any clay. I'm just trying to use things that I have around my house so I don't have to make an extra trip out because, you know, we're trying to all stay at home, stay safe. Okay, so this video is going to cut around a lot because I'm having to film it in short little increments to get it all together. So last night I actually went ahead and filmed the part where I go over the materials and what we're going to be doing. All right, and then all day today, since 8 o'clock this morning, I've been filming every hour on the hour different little parts of this video to show you how the sun makes the shadow of the straw move. Okay, so I'm gonna go ahead and cut over to the clip of me telling you about all the different materials. All right, guys, so like I said, today we're going to be doing a science project where we create our own sundial. First, we have to get all of these materials. So first I need to get a sun tracker, which I have right here. Okay, I'll put that to the side. Next, I need to get cardboard. I got me some cardboard. The cardboard that I got, or that I cut out, is about the same size of the piece of paper. So whenever I glue it, you shouldn't be able to see too much of the paper behind it because it's perfectly glued on here. All right, the next thing I need is clay. I did not have clay. However, I do have a little bit of Play-Doh. That's Jackson's, so I'm just going to use some of that because it serves the same purpose. A straw. I have a straw, blue little bendy straw. And then glue, okay? The glue is so that you can glue the piece of paper onto the cardboard. So I also got tape because I didn't have liquid glue like they showed. I just have stick glue. So I'm going to use some stick glue, but then I'm probably going to tape the sides down as well. So that way the paper doesn't go flying off the cardboard if it doesn't stick. Okay, so stay tuned and I will go ahead and glue the paper on the cardboard. All right. Like I said, step one is glue the sun tracker to the cardboard. I went ahead and did that. All right. I also added a piece of tape at the bottom and at the top, just in case the glue didn't make it stick all the way. All right. Our next step says, put a piece of clay on the sun tracker. Put a stir stick in the clay. Okay. So I'm going to get my Play-Doh out. All right, and it wants me to put that right here. It says put clay here, put a stir stick in the clay. Okay, so there's my Play-Doh. All right, and next I'm going to put my straw. The materials say straw, but for some reason it's reading as a stir stick. But like I said earlier, I'm just going to use a straw. All right, so my straw is right there. All right, so far so good. This is what we're looking like. All right. Step 3, put the sun tracker outside in the sun. All right. It says point the paper north. Your teacher will tell you which way is north. If you decide to do this at home, your parents will have to tell you where north is. There's an app on iPhones called a compass, and that will help you know which way north is. So y'all stay tuned, and I'm going to move us outside so that way we can be facing north. All right, guys, I have walked outside. As you can see, I'm outside. And I have come and I put my sun tracker down right here. I'm not going to mark this time because I want to mark it on the hour every hour. So the first actual time I'm going to mark it is at 8 o'clock. But it is, let me see, It is 7:32 right now, and you can see it's just a little bit over the west line. So whenever we come back at 8, we'll have to see how much it moved, and then I'll go ahead and mark it and write the time next to it. I'm gonna come back every hour to mark the time, and I'm not gonna move this from where it is. It is pointing north right now. I used a compass to help me make sure I was pointing it exactly north. Whenever it is 8 o'clock, I'll come back and check in with you guys. All right. Guys, it's 8 o'clock. I'm coming back out here. The next step on our worksheet told us to come out every hour and mark where the shadow is and write the time next to it. All right, so I'm gonna mark right here. I'm gonna write 8 o'clock. All right, and then it tells us to come back out an hour and write the next spot. Okay, so I will come back out at 9 o'clock and we will check where it is. Now, real quick before I log off, I want you to see how far away it moved from the W. At first it was really close to it, and now it's a little bit further. So let's make a prediction. Do you think it's gonna come back closer to the W, or do you think it's gonna go further away? All right, keep your prediction in your head, and when we come back, we'll check it. All right, guys, checking back in. It is now 9 o'clock. So if you made the prediction that the line would go back up and not down towards the W, then you were correct. As you can see, at 8 o'clock, the line was here, but now it is here. So let's go ahead and mark that. All right, I'm gonna write our time, 9 o'clock. All right. So far, our line continues to move up. We will check back at 10 to see if the line is still moving up. All right, and let's make another prediction. How long do you think it'll take us to get to exactly north? That's what that N stands for, north. Do you think we'll be able to get there by 12 o'clock today at lunchtime? Or do you think it'll take me until 3 o'clock this afternoon? Or do you think we'll get there at all? All right, so I will check back in with y'all at 10 o'clock. All right, guys, this is our 10 o'clock check-in. As you can see, the dial is still moving. Okay, so it's moving upwards. Let me go ahead and mark this right here. 10 o'clock. All right. We're still not up here yet, so keep making those guesses on how long it's going to take us to get up here. All right, there's my dog, Luke. We will check back in at 11. All right, friends, here is our 11 o'clock update. Okay. Oh, try to get to where you can see it. All right, so here we were, started at 8, 9, 10, and now we're up here at 11. All right. I'm gonna mark it on here. 11 o'clock. All right. It looks to me like space in between the hours is getting bigger. Like it started out small, like maybe my pinky size, and it's getting a little bit bigger. And a little bit bigger. So I'm gonna guess that it's gonna be a little bit longer of a jump. Maybe it'll I'm gonna put a little X and guess like maybe here when we come back at 12. Let's see if you can see it. Yep, maybe like there when we come back at 12. I don't think it's gonna make it all the way here, but I will be interested to see if we get here by 3 o'clock. Okay, so I will come back at 12 and we will see if Ms. Marshall's prediction was correct or if I was a little bit off. All right, I'll see y'all then. All right, guys, it is 12 o'clock. I have come outside to check the sun tracker. As you can see, at 12 o'clock it was here. My guess is that it was going to be here, but it actually is all the way over here. Okay, so it made a pretty big jump from 11 to 12. Okay, so I'm going to go ahead and mark that. Well, All right, and then I'm gonna write the time next to it. Okay, so if our dot, I moved the paper a little bit. All right, if our dot is here at 12, do you think it will be here by 1 o'clock, or do you think it's gonna be past there? Okay, my guess is that it's gonna be there, that the gaps are gonna start getting smaller and smaller again like they were over here. Okay, so when I come back at 1, we will see if my prediction's right, if it's gonna be on the north exactly, or if it's gonna be a little bit past there. All right, friends, it's time for our 1 o'clock update. As you can see, our shadow is getting smaller and it went past north. I would say our gap from 11 to 12 and 12 to 1 is probably about the same size. That's just me eyeballing it. So my prediction would be that the next gap, 1 to 2, would be about the same size as 11 to 10, or 10 to 11. So I'll be interested to see if that is true. So let me just go ahead and draw a line up here to mark that and write the time next to it. So that is 1 o'clock p.m. All right. So whenever we come back, I would say it's probably gonna be about here-ish. I'll put a little line there just so we can see if I'm about right. The last time that I am going to mark on our sundial is gonna be 3 o'clock, and I'm assuming it would be over here somewhere. I want y'all to be thinking about why our dial started here and then it started moving this way, and why it might end over here. All right, and then at 3 o'clock we will start taking a look at the questions that are on our worksheet. All right, friends, it is now 2 o'clock. The shadow has made it all the way over here, so it went past where I guessed. So let me go ahead and mark that. It is now 2 o'clock. Okay, I want you to notice that whenever it was 12 o'clock, the shadow was really short. But now that the sun is not right above us, it's more towards the west, the shadow is long and pointing towards the east. That is pretty cool. All right, guys, it is now 3 o'clock, okay? And our shadow has moved almost all the way to the east, which means the sun is coming in from the west. Okay, I'm gonna go ahead and mark this. This is our last one we're doing. So I'm gonna take this inside with me and use it to help me answer our questions. All right, so let's take this straw out now that we're done, and let's look at it. Okay, so at 8 o'clock this morning, our straw was sticking up here and our shadow was pointing more towards the west. That means the sun was coming from the east, okay? And then at 9, it moved just a little bit up. And then at 10, it moved a little bit more. And then at 11, it moved a little bit more. And then whenever we got to 12, our shadow was really short. Okay, and it was pointing almost directly above, like the sun was coming from directly above us, which made the that's what made the shadow shorter, but that's also what made it be closest to the north, okay, because we are facing north. All right, and then from that gap from 12 to 1, I think that is our biggest jump, is what it looks like to me. And then 1 to 2, it got just a little bit smaller, and then 2 to 3, you can definitely see it got smaller. If we kept doing this all the way until the sun went down, from 3 to 4 probably would be about here, and it would continue to keep getting smaller until it looped all the way back around to that 8 o'clock. That just means that the sun rises in the east because it's coming from this way, and that's pointing at the straw, and the straw cast the shadow behind it. And then as the sun moves over us, so the sun's this way, and as it moves over us and starts to set, it makes the shadow go from moving
go from here to moving over here. Okay, so now that we have all of this information, let's go and look at our questions that are on our worksheet.
All right, guys, it is now 3 o'clock. I just showed you the last little marking that I'm going to do for the day, because usually our school day runs from 8 to 3, so I figured that's plenty of markings that we needed to do. So now what we need to do is go back and answer the questions together. So we did step 1, glue the sun tracker to the cardboard. You can give yourself a check. We did 2, put a piece of clay, or we did Play-Doh, on the sun tracker and put a straw in the clay. Did that, check. Number 3, put the sun tracker outside in the sun. I pointed it north. I told you that I used a compass. A compass is something that shows you different directions. So north, south, east, and west, or northeast, southwest, just however you want to read it. And I had that compass on my phone. If you decided that you wanted to do this activity at home with your parents by yourself, if you wanted to try it on your own because you have some of these materials, your parents have a compass on their smartphones. And if they don't, then you can always go to the store and get a handheld compass. All right. Step 4 says observe the tip of the shadow. Mark the tip with a dot every hour. Write the time. Okay, so in the last couple clips, that's what I've shown you, is me going outside every hour on the hour, writing the time and putting a little dot where the straw was at that point. Okay, so number 5, it says, how did the pattern of dots change? Okay, so basically what that question is asking us is, what is one consistent pattern that we were seeing throughout the experiment? And that would be what, guys? That the shadow that was casted from the straw kept moving, right? It started in the west and it consistently was moving up and over. So at first it started west and then it started moving up towards the north. And then as the sun started going down, our shadow started moving back down, right? And it started moving towards the east. And that's because whenever the sun first comes up in the morning, the sun rises in the east. And so that means if the sun's coming up this way and you have something standing completely still and the sun's pointing down at it, the shadow is going to cast behind you, right? So if it's up here, that means your shadow is going to cast this way. Well, the sun is constantly moving. So that means your shadow throughout the day is going to be constantly moving. So the sun's going to start here in the east. It's going to rise. And we noticed that whenever we got to the middle of the day, which was about 12, that our shadow was really small, and about 1 o'clock our shadow was really small. That's because the sun is more directly above you, which means that there's going to be less of a shadow that is casted. And then as the sun starts to drop again, the shadow will begin to grow again. All right, so sun's here, it's going, it's moving, your shadow's going this way, your shadow's going this way. All right, a smaller shadow because the sun's up here. All right, and now the sun's over here and your shadow has to cast back the opposite way. So wherever the sun is in the sky, your shadow is casting the opposite way, except for when it is the middle of the day, and that is when your shadow is at its smallest. Okay, number 6 says, infer. How can you use a shadow to predict the sun's position? Okay, so now we kind of have to draw a conclusion out of everything that we've done today. Okay, so we just got done saying that the shadow moved across the page due to where the sun was at. Okay, so our question one more time is, how can you use a shadow to predict the sun's position? So let's think about it. 8 o'clock, the sun was first rising from the east, okay, which made our shadow point towards the west. And then at noon, our shadow was more pointing straight down and it was really short. And then about 3 o'clock, our shadow was back pointing the opposite way. So we use a shadow to predict the sun's position. Okay, so if a shadow is long and points west, then the sun is in the east. If it is very short, the sun is above us. And if it is very long and points east, then the sun is in the west. It's just that simple. That's our answer. One more time. and I'm going to post it at the end. I'm going to post a picture of my finished worksheet at the end, so don't panic if you're not able to write as fast as I'm able to talk, okay? So if a shadow is long and it points towards the west, okay, then the sun is in the east, okay? If it is very short, that means the sun is right above you, probably about noonish, okay? If it's long and points to the east, then the sun's probably in the west, okay? That will conclude our video for this science experiment. Like I said, I'm about to throw up on the next little part the completed worksheet and what it should look like for whenever you turn it into myself or Miss Belenka. I'm actually made this video, I didn't say this earlier in the video, I made this video for all of first grade, my class and Miss Belenka's class. You're all doing the same assignments each week. So if you have any questions, please feel free to reach out to either me or Miss Belenka. We don't mind helping at all. I hope this video was helpful. Alright guys, so that was our week 4 video. Like I said, I'm not doing a special video this week because I had to film this video about science. Next week I am going to be filming 2 videos. I think we have another science experiment video next week, and I am doing a Mother's Day craft that I'm going to walk your kids through step by step, or you guys who are watching, I'm going to walk you through it step by step because Mother's Day is the weekend after that, I believe. So we're going to make a card for Mom. Super easy stuff you should have at home. If you have white paper, construction paper, crayons, color pencils, markers, anything like that, all that stuff will help whenever we're making our projects. Don't feel like you have to go out to the store and get anything extra. This is just a fun little something that we can do for moms because usually we like to do a craft at school. However, we don't have that option obviously right now. So I wanted to do just a fun little something for you so that way you can give mom a Mother's Day gift. Or if you have a grandparent, a grandma that you live with, or even an aunt or a cousin that's a female that you live with and they're a mother, you can give it to them. If you have any questions, please let me know. I love you guys very much and I miss you. Y'all have a safe and fun week. I look forward to getting everybody's assignments in on Friday. Remember, they're due by 3 o'clock. All right, love y'all.